And last but not least, we have part H of question 2. This is going to be fun. Alright, I'm going to start by finding the oxidation numbers for everything. SiCl4 is a covalent molecule. Silicon is right underneath carbon on the periodic table. So first of all, it's a liquid, it's covalent. You definitely cannot split this into anything smaller. And second of all, because it is covalent, you do have to make an assumption when you find the oxidation numbers. Chlorine is considered to be the more electronegative element. So I'm going to assume that chlorine has the negative electronegative oxidation number. And I'm going to go with -1 because it is the most common ion for chlorine, which means that silicon will be +4. Okay, magnesium is 0. This is -1, +2, and this is 0. One more thing, this is a solid, so this is insoluble, which means that splitting it is also going to be an issue. All right, at least I know that the oxidizing agent is going to be SiCl4, I think, because it goes from SiCl4 to Si, so it's really the silicon. And the reducing agent is going to be magnesium. All right, I'm going to start with the reduction process. So we're going to look at the oxidizing agent first because this is actually really interesting. So for reduction, if you think about what is happening here, and then we have SiCl4 going to Si. Now, SiCl4, silicon tetrachloride, is a covalent substance. So I have Si, and then there are 4 bonding pairs of electrons. I don't know why I wrote H there. Cl, 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 and then Cl. Okay, 4 bonding pairs of electrons around this. And what is happening, and I know this because if you look at the change in oxidation numbers, it goes from +4 to 0 for silicon. So this molecule must have gained 4 electrons. And the question is, where do the 4 electrons go? To answer this question, they actually go into the 4-chlorine. So if you remember once again, chlorine is more electronegative than silicon. And initially, the chlorine needs to form covalent bonds with silicon in order to have a full share of 8 if you really want to use the octet rule. But now, because there are 4 extra electrons, the chlorine no longer have to form covalent bonds. They can just accept the electrons and become ions. So actually what happened when the 4 electrons come in is that they're going to form 4 Cl minus ions as a result of that, which leaves the silicon being neutral at the end. Okay, so what about states, which is the other interesting question here. Silicon tetrachloride, in this case a liquid, you get a solid, but you cannot write the state of chloride ions to be aqueous because there is actually no water being present. There's no solution from anything else in this reaction. So I'm going to have to stick with liquid and assume that there is a liquid of chloride ion somewhere, which I think will come in handy in a second. So if we talk about the oxidation, you have magnesium, which is a solid, going to magnesium chloride. And I think this makes a lot of sense. If you have the magnesium solid coming into contact with the silicon chloride, it's going to precipitate with the chloride ion. So the chloride ion is going to go on this side, and I need 2 to balance that, and it's still liquid. So that's solid, and that's solid, which means I need to have 2 electrons on that side. So what happened here is the magnesium is going to lose 2 electrons to become magnesium ions, and the magnesium ions will immediately precipitate with the chloride ions that's already being formed from the silicon. Hence you have a solid and you have the other solid as the product. I think that's it. Now this is a hard question that it's very unlikely to come up in VC, but you never know. You never know. I've seen more interesting things.